So in model-based design, we have a variety of different options, and I call them here model usage examples. And this table is taken from ee6083 table 1-1. It really tells you a little bit about the process that generates the lifecycle data. So it would be the system requirements and system design processes, the software requirements, software design processes, and the software coding processes. So basically everything kind of related to ee178C slash ee133, sorry, 331. So let's look at it. So, if you look at kind of a traditional way, we come up with system requirements and system design, and then in the software requirements, we come up with high-level requirements, then low-level requirements of software architecture, and finally source code. Now, so if you design, the first thing you could do is you could say, well, I'm sticking to my system requirements, and of course, within my system requirements, I will have some requirements that are allocated to software. From those requirements, I will come up with some kind of high-level requirements, and from these requirements, I come up with a design model, which I will implement using, for example, Simulink. Yeah? Then based on that, via code generator or some other way, I generate source code. So that's one way of doing it. So in this case, you may keep these textual, and for these you choose some kind of modeling language or modeling technique. So the second example here is where you say, well, let's use models for all of these software requirements. In this case, I have to come up with some high-level requirements using a specification model, and some more detailed requirements or architecture using a design model. Yeah? Of course, you can also do the opposite of what you do here, using a specification model, but then keep the design details textual again, like you would do in some traditional low-level requirements or traditional software architecture. And finally, you can also say, well, I'm not gonna have this these different levels of granularity. I just come up with one design model, and this can be either just covering the software requirements, or it actually can also become part of the system requirements or system design processes. Yeah, so these are 5 different examples, and more or less the next couple of slides just give you just a little bit different way of looking at this. So let's look at that. Let's look at this little block diagram. And what do you see here? You see originally the system requirements and design, and then at this dash line, below the dash line is everything that's related to software. So what we're doing is we come up with high-level requirements, then actually we come up with low-level requirements in software architecture, and remember, these need to be at the level of detail so I can actually derive source code directly from it. And finally, of course, the source code gets turned into executable object code. Okay, now, so if you look at these, what I can first do, I can say, well, okay, so now one thing I didn't do in here is that you see all these arrows with these little textual things next to it. These are all the verification efforts, and actually this means A4 table, objective table A4, objective 9, 10, 11, 12, 13 have to do with anything related to software architecture itself. Yeah, so you can actually go there. Now, so first thing I can do is say, well, I keep the high-level requirements textual, but I'm going to take both the software architecture and low-level requirements and replace them by a design model. I'm going to, for example, use Skate or Simulink to actually get my equivalent for the low-level requirements in software architecture. And then what I'm going to do is I'm going to take these models to generate source code, either by some tool that automatically generates the source code, or I can do this via some other means. So that's one way of doing it. Then realize, since you're actually mixing high-level requirements with design model here, you need to, of course, make use of ee331 specific guidance. Whereas for the other parts, ee178C just applies. Now, another way of looking at it is by just saying, well, I'm having high-level textual and low-level textual requirements, like I had in a traditional sense. But then some of the high-level requirements, for some of the high-level requirements, I'm going to use a design model. And heck, this may even include portions of the system requirements. That means that the this portion of your software lifecycle must include the guidance that's set in DO331. Now, so this is again another one. In this case, I decide to use both textual high-level requirements and a specification model and a design model. And then finally, of course, just. So these are really all different examples of how you can mix and match model-based design and development and verification activities, of course, with traditional textual or traditional methods that are kind of tend to be specified in DO178C. Now, so chapter 40 of the Spitzer book really talks a little bit more specific, and really the remainder of the slides all about this. All that some of these tools out there, like the MathWorks tools, provide you a whole suite of tools that you can use when you're doing model-based development, design, and verification. And here in this case, really it tells you, okay, for example, in model development, I have, of course, basically the Simulink or Stateflow editors. You have been using Simulink in your projects, and then, use the simulation engine to support some of your development. To support some of your development. Then, of course, in the verification activities, you're gonna, help out, with the generation of reports. You can actually look at the design model and use the model advisor, and also do the model coverage tools. So in this particular case, you see that all the yellow boxes here specify activities that are supported by tools in the MathWorks, for MathWorks. Yeah. Same thing for test case generation. MathWorks has a tool called Simulink Design Verifier that helps you come up with test cases. Now, of course, realize this comes back to in the earlier slides that I talked about verification. This can help you, and this must be used in combination with the usual test case generation as specified under DO178C. Now, in Blackboard, I have some other handouts too relating to the skate tools in addition to the ones for the MathWorks tool. Now, so again here for the executable object code, one of these days I'll get that right. In other words, these 3 slides are really there to indicate some of the MathWorks tools that are being used in model-based design and development. And you see they have a pretty widespread role in all the different activities. Now, another way of looking at that is, which I got from another paper that's also on Blackboard, is where I indicate for each of the, what I do, I did the life cycle a little different, requirements, model, source code, object code, and I just kind of indicated, what kind of activities, what kind of tools you could use for each one of those. And this is a little different, it's a little older, so let me tell you that these 2 slides, the previous slides that I talked about, are probably a little bit more recent, so probably a little more in line with the more recent versions of all the MathWorks tools, whereas this may have some older tools included as well. So this is there just for your information. On Blackboard, again, I have a couple of handouts on the MathWorks tools as well as on the skate tools, but besides that, there's a variety of other model-based design tools, like, for example, UML and a bunch of others.